Okay, here is a typical Alex question on oxidation and reduction. It's giving us three chemical equations here, and it's going to ask us a couple of things. Number one, is it a redox reaction? We have to answer yes or no. And then we have to actually type in what is the reducing agent and what is the oxidizing agent. Alright, so how do we tackle these? Well, first we have to assign oxidation states. And so let's do that for the chlorine. Remember, if it is an atom or a diatom by itself, then the oxidation state is 0. So the chlorine is 0 here. The tin is also 0 right here. And then we have to assign oxidation states right here. So each of the chlorines, this is an ionic compound, is a -1, and then the way I do this for my counting purposes, 4 times -1 is a -4 up there, and then that means that in order for this to be a neutral compound, 10 has to be a +4. So 1 times +4 is a +4. My accounting adds up to 0, and so I know I'm right. So the oxidation states are chlorine 0, tin 0, tin in the tin chloride is a +4, and the chloride is a -1. Right, so now I draw my lines. The chlorine goes from a 0 to a -1. It is being reduced, and therefore by definition it is the oxidizing agent. Okay, so in Alex I write the oxidizing agent in this case is going to be, type in Cl2. Alright, let's look at the tin. The tin goes from a 0, my lines are going to look really bad here, so 0 to a +4. That is being oxidized. The oxidation state is going up, 0 to a +4. It is being oxidized. Therefore, by definition, it is the reducing agent. So in this case, the reducing agent is Sn. So yes, that is oxidation reduction. We have tin, and the chlorine is the oxidizing agent. Let's go to this next one. Again, same things, just start assigning oxidation states. Iron is by itself, therefore it is a 0. Each of the chlorines is a -1, so for accounting, 2 times -1 is -2. So that means that there's one nickel that has to be a +2. 1, which is down there, times +2 is a +2, and so those do add up to 0, and so I'm good right there. Let's come over here and assign oxidation states. So this is iron 3 chloride. Each of the chlorines is a -1. 3 times -1 is a -3 for accounting up here. I have one iron, so the oxidation state that has to be a +3. And my accounting will show that there's one iron right there. 1 times a +3 is a +3. Those do add to 0, which is the state of that compound. So iron's a +3, the chloride is a -1. Nickel's by itself, so that is a big 0. So let's draw our lines. Iron goes from a 0 to a +3. It is being oxidized, and therefore by definition it is the reducing agent. Okay. So it is being, yes, this is redox. The reducing agent is Fe. The nickel is going from a +2 to a 0. Its oxidation state is going down, +2 to 0. It is being reduced. Therefore by definition it is the oxidizing agent. And so what I would type into Alex over here is the whole compound, NiCl2. Alright, let's look at this last one. Again, assign oxidation states. Each of the oxygens is a minus 2. We're counting. 2 times negative 2 is a negative 4. I have one carbon right there, so it has to be a plus 4. 1 times 4 is a plus 4. That adds up to 0, so there's my oxidation states. Water, we'll see a lot. Each of the oxygens is a minus 2. Hydrogens is a plus 1 for counting purposes. 2 times a plus 1 is a plus 2. 1 times minus 2 is a minus 2. Those add up to 0, so we're okay. Okay, each of the oxygens is a minus 2. And so for counting purposes, 1 times a minus 2 is a minus 2. Each of the hydrogens has to be a plus 1. 3 times a plus 1 is a plus 3. If I add those up together, plus 3 plus a minus 2 is a plus 1, but that matches that charge right there. So I'm going to erase that. So hydrogen plus 1, oxygen is a minus 2. Each of the oxygens is a minus 2. 3 times negative 2 is, for counting up here, is a minus 6. Alright, the hydrogen is a plus 1. So 1 times plus 1 is a plus 1. Now keep in mind we have a minus charge. So this whole thing has to add up to a minus charge. And the only way that can happen is if the carbon is a plus 4. 1 times plus 4 is a plus 4. So if I add a plus 1, plus a 4, plus a minus 6, those all do add up to a minus 1. So I know that looks like a jumbled mess, but the hydrogen is a plus 1, the carbon is a plus 4, the oxygen is a minus 2. So let's start drawing our lines. Carbon goes from a plus 4, big line here, to a plus 4. It's not being oxidized or reduced. Oxygen goes from a minus 2 to a minus 2 on either of those, so it is not being oxidized or reduced. And hydrogen goes from a plus 1 to a plus 1 in both places. This is not a redox reaction. Why? Nothing is being oxidized and nothing is being reduced. So just mark that in Alex and you are done. So this is how you would fill in your Alex table, and you should get this one right.